Hello and welcome. In this video, we're going to explore the sweep and plotting functions of ADIsimRF. ADIsimRF is an easy-to-use RF noise and distortion calculator that can perform cascaded analysis of signal chains with up to 50 elements. So here we are on the ADIsimRF home screen, loaded with one of the example signal chains that come with the software. This is a 40 GHz receiver with 10 stages, where the input signal is mixed down to a first IF of 2160 MHz and then down to a second IF of 140 MHz. Let's start with the frequency sweep. When we do a frequency sweep, we need to decide whether we want to sweep the radio frequency, the first intermediate frequency, or the second intermediate frequency. In this case, we will choose to sweep the radio frequency. So to do this, we select the Graph tab and then select Frequency Sweep. In this window, we select which stages to sweep. Since we want to sweep the radio frequency, we just select the top two stages, which are operating at 40 GHz. Next, we select Get Frequency Range. When we do this, the program figures out the common frequency range for both devices. For example, if one device had a frequency range of 35 GHz to 45 GHz, and the second device had a frequency range of 40 to 50 GHz, the available sweep range would come up as 40 to 45 GHz. We can now tweak the sweep range, making it narrower if we want, or adjust the step size. In this case, to make the sweep run quicker, I'm going to adjust the step size from 100 up to 500 MHz. Next, we hit Update and our plot is generated. The default traces that appear are output power, OP1 dB, gain, OIP3, and noise figure. However, these can be easily changed using this window on the left. So, for example, we could switch from viewing OP1 dB to IP1 dB by selecting and unselecting the appropriate traces. We can also move traces to the secondary axis and add markers. This puts our y-axis out of alignment. We can fix this by adjusting the scaling on the secondary axis. We can also add or adjust axis labels by typing into these windows. Once the plot has been configured, the plotted data can be exported to Excel by pressing this button here. This launches Excel and dumps all of the trace and axis data. Let's now look at the gain sweep. If we look back at our receiver, we see that there are two available variable gain elements in the signal chain: a DSA at the first IF and a VGA at the second IF. So we must decide which device we want to sweep. Clicking again on the Graph tab and choosing the gain sweep, we see at the top there is a pull down to select which variable gain element we want to sweep. Let's decide to sweep the gain of the AD8368 IF VGA. And as soon as we do this, the results are plotted. Just like the frequency sweep, we can select which data to plot, adjust and label the axis, and export the data to Excel. Let's now take a look at the power sweep. This works in exactly the same way. In this case, you select your min and max RF powers and the step size, and then you hit update to generate your plot. It's important to note that ADIsimRF does not currently contain an RF power compression or saturation algorithm. So as you increase input power, output power will follow in a linear fashion and will not compress. RF power compression is a feature that we hope to add in future revisions of ADIsimRF. Now let's take a look at the last plot, the level plan. The level plan shows the cumulative cascaded performance at each point in the signal chain. For example, the output power of the ADL5240 is around plus 2 dBm, and the combined OIP3 of all of the stages up to and including this stage is 29 dBm. This level plan is useful for assessing how well balanced the signal chain is. In this case, we see that output power, OP1 dB, and OIP3 track each other for the most part as we move up the signal chain. If we had seen a big increase in output power without a corresponding increase in OIP3, that would be an indicator that there is a weak point in the signal chain, where device overdrive is causing IMD3 distortion. Like other plots, the level plan plot is configurable and its data can be exported to Excel. Thank you for taking the time to watch this video. For more information and to download ADIsimRF, please go to analog.com/ADIsimRF.